Hi guys, this is Miss Raina coming to you from C347 here at MacArthur High School to talk today about circular motion. So let's go ahead and get started. At the very top of your worksheet, flip note circular motion. And here's just a real quick overview. You guys already have that on your paper. And here are a couple of examples. I'll show you guys this video in class. It's pretty funny. Here we have a situation where there's a bunch of kids on a merry-go-round and a grown woman who has no earthly idea what she's going on there, but when she falls off, to a lot of the kids' surprise, she doesn't fall straight out. Whoops. She falls in a line tangential to her original direction of travel. Alright, so how fast does something go around in a circle? We'll watch this video in class tomorrow too. It's the same as any other time that we've ever done velocity. So take your distance, which in this case is the distance around a circle, or 2 pi r, the circumference, and divide that by your time, which in this case is the time it takes to make one revolution. By the time we've done our lab today, we all understand that that is a period. Alright, so let's revisit the carousel story and ask the question again. If I sit on the outside and my brother sits on the inside, which horse moves the fastest? Well, if you remember from my story today, both of us do. So how does that work? We all make a revolution in the same amount of time, but the horse on the outside will cover more distance than the horse on the inside. So if we look at linear speed or tangential speed, then I'm going faster. If we look at angular speed, then we're both going the same way. So the next question we ask ourselves is, if we're traveling in a circle and we're on cruise control, well, do we have acceleration? And I'm sure you guys know by now, acceleration is change in velocity, and that can be change in magnitude or that can be change in direction. So if we're turning, then yes, we definitely have acceleration. Okay, so at this point, let's just recap a little bit. An object will move tangent to the circle when rotating. Tangent means it's perpendicular to the radius. It's only touching the circle at one spot. The distance around the circle, easy, that's the circumference. And another word for the tangential speed, we can call that linear speed. As far as the carousel, which horse moves the fastest, inside or outside? Well, you guys know the answer. It's both of us. If we talk about linear speed, then definitely it's the outside horse. But if we talk about angular speed, then it's both horses are going the same way. So from the story in class and from the explanation here, you guys go ahead and write down for number 6, A and B, your own understanding of the difference between angular speed and tangential speed. And if you're waiting for the equations in the box, they're coming very soon. So again, does an object traveling in uniform circular motion have acceleration? Yes, it's turning. So because it's turning, its velocity is changing and it accelerates. How does an object accelerate in a circle? Well, it's got to be pulled toward the inside of the circle. So if you think about your steering wheel while you're driving around in a circle, which way is your steering wheel pointed? It's always pulling you toward the inside of the circle. And so that's the way that you accelerate. You can calculate centripetal acceleration with this equation right here. You can go ahead and write it in your equation box. Okay, if you'll bear with me, we'll do this example in class this time. My smartboard isn't working so great right now. Maybe I'll put up another video full of examples. But in the meantime, let's go ahead and flip the page over and we'll talk a little bit about centripetal force. So if we have an acceleration, there's got to be a force causing it, and it's centripetal. What does centripetal mean? It's got to be center seeking. In this case, it's Newton's first law that applies, because normally an object in uniform motion would stay in uniform motion. It would go in a straight line, but because we're applying a force, we're causing it to curve its path. We're causing it to turn. Notice that this is not centrifugal or centrifugal force, that word that people say all the time. We like to call it the F word, because it's not a real force. Here again is the law of inertia, Newton's first law, so you guys can write down how it's influenced. Here's just a couple of examples. If you've got a car going around in a circle, what provides that force to keep it turning toward the inside? It's the friction. If you've got a bucket of water and you're swinging it around, what provides that force to keep it moving and turning constantly toward the inside? It's the tension in the string. Keep in mind, this centripetal force is not a new kind of force. It's just a direction. It just means that it's a force that is directed to the inside of the circle, toward the center of the circle. So this is not a new force that keeps the moon going around the earth. That was always gravitation. We call it centripetal force because it's pointing toward the center. All right, so what about centrifugal force? That F word is a lie. Doesn't exist. People think that when they're going around a corner and they feel themselves being pushed toward the outside, that that's a force. Really? No, that's not what's happening. What's happening is if you're going around a corner, your inertia is resisting change in motion, while the car under you is changing its motion quicker than you are. So what you feel is your tendency to stay in the same path. All right, we're not going to spin a cat by its leash. We'll leave that free body diagram for tomorrow. And I think we're going to go ahead and stop right here. I'm sorry for being a little bit sporadic, but go ahead and take a moment to just write down on the other side of your paper equations for centripetal force. Now that you have, let's see, tangential or linear speed, the circumference of a circle, and centripetal acceleration. We'll worry about critical velocity and angular speed tomorrow in class. Thanks again, everybody, for hanging out through one more flip video. We'll see you tomorrow. Make sure you write down any questions you have.